So, on the bench is a 6633A, which is a 50 volt 2 amp power supply rated at 100 watts. The unit has some issues. I don't know exactly what they are. I got this from a guy called Gavin locally, who was very generous. He actually gave this to me and said, if you can fix it, great. If not, don't worry about it. Probably give him something for it. Now it's got a fuse holder issue, and it's got a fuse piece here taped to the top. Let's get all this off. So he's very safety conscious, this guy. He really did think about things not being good. A fuse holder part's missing, which is something that happens from time to time. Sometimes it happens on gear which has been decommissioned, so it doesn't accidentally get powered up. Other times it's because they want to take the fuse holder out to hide the fact that maybe it still works, but they like a new one. Come across that before. I don't know if this will actually pop in there or not. Does that fit in here too? It does, look at that. Sweet. So what fuse is in this thing? 1 amp. 1 amp? Really? What does it need? 2 amps to 250 volt. So let me just upgrade this fuse. Probably finally put it in, it goes pop. I haven't got many of these actually. I think I've actually got a box of fuses somewhere. One of those like assortments kits, one of them. So I popped a new fuse in there, 2 amp fuse. Like I said, I don't know if it's on the right voltage or not. It hasn't been remarked by someone. So I think we need to open it up now and actually have a look. Let's actually just do these screws up so they don't fall out really. I'm surprised they don't fall out already actually. There's a modification for these. It's also an option I think on these where you can actually have binding posts on the front panel. So that's something I'd like to do to this as well. So let's open this thing up. So there you go, that's the inside of it. What year is this thing? 1987. That's what's marked on the chip down here is 1987. So yeah, old device. Not many caps in this thing. Yeah, there's an orange one under here which is wobbling slightly. That might be a sign of it extruding itself. Usually when they put in the flush with the board and when it starts wobbling, it means it could be popping up a little bit. So I need looking at. Do I have caps I can put in here? That's the question. I know I'll have some of them. Do I have all of them? I think I want to recap it before I even power it up. Yeah, the board is keyed. It's got like little slot keyways in here, which you probably can't see too well. And the board looks like it will slide to unlock. So a couple of connectors which you'd have to take off there and here. And I think it will just maybe unbolt from the back panel and then slide forward. So it's not too bad to get it out, it looks like. So we've got some studs here on the GPIB. Right, so those two studs there, those have to come off to get it out, I think. And maybe there's a couple of screws holding it down as well on the actual board. Yes, I think that's got to come out so I can check the caps at least, very least check the caps. Usually the big caps like these ones over here, they'll probably be alright. Smaller ones probably aren't so much. So I wanted to check the first thing was the switches for the power supply to make sure they're actually set to the right voltage. There's two switches here. Sometimes it's jumpers and or links which are wired on or whatever, but this time it's got switches. HP is quite good for that actually. Agilent, Keysight, whatever. So switch up, switch down, and there's a marking on the PCB here which shows which way they should be for each voltage, which I'm going to try and show you now. Right, so there's the two switches and there's the markings for the PCB which tell you which one's which, what they should be set to. That looks good. Let's do a quick transformer check. There and there, so power switch is turned on, and well, I think it's turned on. We're getting mega ohms there, that can't be right. Let's turn it on the other way, shall we? Also mega ohms, oh, that's interesting. Why? Just fuse I put in dead. Oh no, I've lost it. Or something else going on. Oh, fuse is good. Could be a fuse holder. Don't think this fuse holder wasn't actually in this unit, but it does fit. I can't check the fuse holder. It's on the bottom of the board. I can't contact the connections. Right, how I set that is to take the board out. So why are we seeing an open circuit on this thing with the power switch on? That is interesting. Power switch goes where? Under the board. Can't see it. Okay, so some of these wires in this bundle of power switch. No idea which one. Probably this pair. Probably that one there. Okay, the reefer is in one piece. Actually, it's three reefers there. Three of them. 3 times the trouble. So I'm going to try and take this PCB out, obviously, and I want to get this bar here out so I can get to these connectors a bit easier to get them out. And also, you need to actually get the board out as well, so it's probably going to be in the way. So I've taken these two screws out. It looks like it slides forwards, but it's got two nuts on the side of the transformer here, which need to be loosened so it will slide. Only loosened, I think, not completely removed. There's another one over there somewhere. Just there. Just get to it. Okay, I think that's loosened. There we go. So that should hopefully move out of the way. Once I take the wires off it as well. There's wires attached to it. It's not going to work. Okay, here's that out of the way. It's got these washers on, I have to be careful trying to get those back in again, it could be a bit of a pain. Put it, stick it on this side, stand it up so it's dropping out side by side in the same orientation so I don't get those mixed up. Let's keep it on the same side, it'll be right. That's that. These plugs over here. Front one goes to the front, rear one goes to the rear. Okay, easy. Then we've got this other 2-pin plug here. Like that. So far so good. Does nut drive fit these as well? Oh, not quite. Oh, just. That's that. Piece of these screws. It's not the right screwdriver for this. It's almost right, but not quite. So only one of those 3 screws had a locking washer on it. So that's interesting. Oh, it's moving. Well, I can get that far. Now what? I'll come back when I get it out. PCB is out, that's a bit of a struggle. Basically there's a nut on the side of the transformer, or the bolt coming through the side, which this plate was mounted on before. I had to take the rear one out. Probably wouldn't be easy if I took the front one out as well, but the front one kind of went around it as alright, but the rear one was in the way a bit, so I had to take that one out. And obviously the ones which attach to the GPIB. So basically I had to tip it up, angle it. I should have recorded a video actually. Just angled it up and then try and wiggle it out. So it was a bit fiddly getting it out. Obviously I had to take this wire off as well. I forgot to show that. Now we need to find out why we got no AC connections from the transformer going through this board. We've got reefer caps on here which are cracked. I can see cracks in that cap. So that needs going. I mean, do I power it up and watch it go bang and catch some smoke? Maybe. I don't know. Is it worth risking it? Flip it over, look at the back side. Haven't looked at this yet. Fuse holder connections look alright. AC connections look alright. And it goes through the board and it travels around here somewhere. So it's a double-sided board obviously. And try to see where they go. So the trace that comes across here is the main AC lines, I think. So AC line comes in here, goes to this end of the fuse holder, goes back that way to that end of the fuse holder, which then cuts across the bottom, the top of the board here. So it comes across then from here, or there. There's 2 tracks. Where's the 2 track? One's coming across this way. Am I missing something here? Maybe. No, I mean if you see the trace. So this one here is definitely the one which comes from this terminal on that fuse holder. Comes across, goes underneath the reefer cap, which means it probably does go to the reefer cap, and up to the switches and these terminals up here. So we need to check the fuse holder, see if it's actually working. So based on the fact now I can see the tracks, I could have actually tested this without taking the board out. But the board had to come out anyway, so no real loss. So I've got this propped up so I'm not flexing the board too much, I'm pressing on it. So we'll see between the fuse holder here and here should be fine. Yep. And from here to the reefer cap, which is over this way somewhere. So yeah, it's actually got, let's go through the fuse holder. Okay, and it comes over here to these connections. So if I go from here to one of these, goes to that one. Oh dear, that's looking concerning then. So it is getting to the transformer side from there. Let's check the other side. Where's that go? Yep, that's going to there as well. So I do actually have two connections going to this socket here, which go through to the switch. So it's actually switching double pole. So here to here I should have a transformer winding, I think. Maybe. I might have to look at the circuit diagram, that's right. Okay, let's do some testing on the chassis. First we'll check the power switch. I don't know which ones are which. Can't tell, we'll figure it out. Can I get into there? I can. Nothing. Nothing. Change the switch. That one's working. Yeah, that one is not working. Could it just be a bad power switch? Those two are definitely conducting. These two definitely aren't. And it's a double pole switch. I think the switch is bad. That'd be brilliant. Just work it a bit. There we go. Now we've got something. Dodgy switch. Let's just verify the windings whilst we can, because we know how to do that as well. I'll just look at the diagrams. I wonder which one's which. I'm guessing that's pin 1 this end. Let's find out. So 1 and 2 should have something. We do. 1 and 3 we have something. We do. And 4 and 5 we have something. We do. Right, transformer's good. Bad power switch. Probably just lack of use. It's been left on its entire life or something. So yeah, okay. That will probably be something I need to pull apart maybe and clean. I don't think I've got any switches of that size, but that's okay. We've eliminated that. We know that now we've got a bad power switch, which is why that wasn't working. Okay. Yay. So power switch is bad. I'm going to try pulling it apart, because sometimes you can actually repair them and just fix them up. If I can get both sides apart. I've got one side popping out. The other side I'm trying to get a spudger into. Come on, here we go. There we go. It's out. Now it's all got over my floor. That's it, it's ruined now. Never going to find those bits. So this is what's inside the switch. Obviously here's the head of the switch. And you've got those two posts inside there which are hollow. What happens is you have these springs which go inside those posts. Like that. Okay. Now on the end of those springs you get these little ball bearings. These sit on the end of those springs. Okay. So then push them against these contacts. And this is on the side you can see. And you can see the little line where the ball bearing's been running on that contact. Right. So it's been pushing that side. So the contact is in a switch in this orientation. Right. Although it's not in focus right now. You flip them over. And the contact is made between these little domes and the hinge point of those switches. So the hinge point is one half of the contact, the dome part is the other part, and also you've got the mating part inside the switch as well. Let's look at that. So there's the inside of the switch. So there's the hinge part which it sits on, and you can see how dirty those are. Look at that, really dark and dirty. And there's the other contact at the bottom which those little posts touch onto. Okay, so all of that needs a really good clean. This side is what looks the worst. The actual other part looks not too bad, but these need a really good clean up. I'll fix all that up, clean all that up, and then this switch should be good as new. Well, almost anyway. Alright, so I'm going to give us a clean up, some deoxit. A bit on these. Don't need much, just a dribble. This stuff's really expensive, so you don't want to waste it. And inside the switch, obviously. And the excess, which is dripping out the tube, stick it on the cotton bud. Yes, I'm a bit of a miser with it. So I'll give this a clean up, which you can't see me doing, but I'm going to give it a clean up, and yeah, there's a bit of dirt coming out there, alright. Yep, definitely dirty. But you can see it's dirty. I might need to use something more aggressive than a cotton bud on it, and a bit of deoxit. We'll see how we go. Deoxit is usually pretty good at doing stuff. I'll do this and I'll come back. So that's what the switch looks like now after I've given it a clean up. I can see it's looking a lot better. My trick now is to try and get this thing back together. That should be fun. So I've got a bit of dielectric grease here. I'm going to shove this in here The main reason I'm going to use this is because it helps hold everything together, so when you're trying to reassemble it, things don't just fall out of place and shift and just go flying or fall off. Put a bit of this in there and that will help to hold it all in place when I'm reassembling it. Right, that's all greased up, ready to go back in again now. Put dielectric grease on the springs, on the ball bearing, on the actual switch contacts. That's all in place. Now the hard bit is assembling it and not having it pop out of place when I'm putting it back together. So it's got this dot on top of the switch. That has to be in the correct orientation. That has to be at the top. Okay? So I need to make sure it's actually that way up. Now these ball bearings look like they're not going to fall out. This is good. So I can probably assemble it upside down. We'll see how lucky we get. Switch top is in place. All I've got to do now is push it down. And if I do it quickly enough, it should bed in before all the bits fall out. Okay? You got your fingers crossed for me? It feels like it works. Let's test it. Alright, let's check this, see how it actually works. So look at that. If I put the contacts there. So lead resistance is, yeah, basically 0. So with the wires and the switch, that's looking good on that side. Cycle it a few times. Oh, have I lost connection or is it? Oh look. That one didn't go that time. And again. Oh. Is that side not actually toggling over, maybe? Yeah. Sometimes it isn't actually working. Even though I've done all that work to it. Yep, this switch needs replacing. That side's working alright. This side is still a bit dodgy. When it closes, it's okay. If it moves at all, it works fine. The issue is that it's not always moving. I don't know, now it's right again. So I don't trust it. I think if I can get a switch I will replace it. But it'll probably do for now. Alright, okay, now we've solved that problem. Well, semi-solved that problem. It's kind of working now. It's better than it was when we got it. So that's all we can really say about that. We need to check some caps and stuff and see what's going on. So we've got 6 caps on this board, I think. I think that's all there is, only 6 electrolytics. That's surprising, it really is surprising. And also we've got these reefers over here which need to go. I'm not quite sure if I've got all the parts I need to replace these. I've certainly got the 0.22s, I'm sure I've got those. So you've got 0.22s and 2.2s. Yeah, 2.2 nanofarad. Or 2200 picofarad, however you want to say it, but yeah, okay. We've got a Sprague tantalum cap over here, looks like tantalum. Another one over here. Then we'll get the cap tester out on the back and just check the caps before we change them out. I just want to see what they're actually like. Let's check for any problems with these tantalums, in case it's shorted or something. That's fine. And that's fine. Any more? One over here. That's fine. Another one over here. That's fine. RT1. What the hell is RT1? That's looking interesting. .8K, whatever it is. So I went around and tested the caps and I forgot to hit record because I'm a dumbass. Anyway, they're all good apart from the reefers, which we know are like a bomb waiting to go off. So all the other caps tested good, so I'm actually not going to change them. I'm going to leave them alone. I'm going to have to bodge just a little bit because I've got these little Y-class reefers in here. I don't actually have exactly the right parts. So these ones have got 2.2 nanofarad over here, and over here we've got some 4.7 nanofarad. I don't have either of those. I've only got 3.3 nanofarad in Y-class, different package style. But the reefers, they're going to be bad. Over this period of time, they're going to be bad. So if they're relatively new, I wouldn't be worried about it. But they're, you know, 30 years old, so time to replace them. I'm going to have to use these type, which are not the right values, but it probably shouldn't matter in the applications they're in, not really. This is mains filtering, and that's tying the outputs to the ground, so it's got a slight ground reference there to the actual outputs, so I think it'll be fine. Not ideal. If you've got a different opinion on that, let me know. Chuck it down in the comments. Ordered a whole bunch of capacitors the other day, but unfortunately X and Y class caps weren't part of that. So it seems I've been a bit remiss there and I actually need to get some. Just putting fresh solder on these to make them easier to desolder. Makes a lot of difference. Now being a double-sided board, this could be a bit tricky to get them off as well. We'll see how we go. Especially on the earth plane over here. There's a ground plane over here for the earth, and also the output terminals, which also got a big plane, so it's a lot of thermal mass there, which is, even this is struggling to melt right now. A bit more heat. So there's two approaches I can do this. One is to try and pull them out with heating, or I could try and desoldering it. Let's see if I can pull them out with heating, which is the easy way to get them out sometimes. Sometimes using a desoldering gun works quite well. They will just literally fall out the board, but I'm not sure it will in this case. Here's one, and that is cracked. I'll use a desoldering gun afterwards to clean the holes out. Here's the other one, also cracked. Let's use a desoldering gun on these ones. Use both techniques, demonstrate both. Now if we're lucky, it's left enough clearance on the side of the hole and it'll actually fall out. That one's not going. I think it's a big ground plane, that one. Or a big plane maybe. Right, so here we go. Yep, that's out. Looking worse aware. This one here is not quite out. Now it's out. That's cracked. Next one is not out at all. We have to walk this one out, I think, like we did the other one. Okay, that's out as well. And also cracked. So there you go. There's these caps. Now you see this one here is actually opened up. See, there's a gap in the side of it. It's actually opened. So there's a crack right across, and the end's all cracked. This is all cracked, and we get the light on it right. You can see the actual fracture lines, see the stress marks inside them. There's little fine lines. Sometimes you have to get the lighting on it right to see them. So that one's actually opened up. That's really close to failing completely, if it hasn't already. This one here doesn't appear to have done. That's not opened up yet. Not quite. Yeah, that's opened up that end as well. And also the big one. Big cracks through the end. These are the ones which really go. When these ones blow, they blow the top off. And you got the smoke and, you know, fumes, and these ones really smell. So this is where the one which usually blows really badly because it's across the mains. Whereas these ones may or may not go because of where they're situated. So yeah, this is why you replace river caps before they go bang. Right, I've got the caps in place. Let's solder the things in there. So the reason I'm using X and Y class caps because it's a standard thing, right? X goes across the mains. So across the phase and neutral is where X class go. Y class go between the ground or chassis or whatever you want to call it and either the neutral or the phase, and they're designed to fail in different ways. X class will fail as a short and blow the fuse. Y class will fail as an open. Generally, that's the theory anyway. So you have to make sure you use the correct class or the correct place, otherwise you could have some other problem that comes up. But basically, as long as you're using the correct class as per original manufacturer's spec, you should be fine. And the manufacturers won't usually get it wrong, I don't think. So I'm just saying to my live stream audience here, because I'm live streaming right now, so I'm recording this. These desoldering guns, I had someone commenting about their gun blocking up all the time, and one of the modifications I did to mine, apart from putting a switch on the front so I can power the thing on and off on the front panel, is putting some of that wall stuff in here. I've got a brass wall, like tip cleaner wall, and I've put some of that in here, probably, you know, about quarter full, half full maybe. You can probably see a bit there. And that does one thing, it catches all the big lumps of solder which gets stuck in it. It catches it all and stops it getting back to the filter in the back, the little cloth filter. If you get it sticking to the cloth filter, it clogs that cloth filter up really quickly. It will cause you a loss of vacuum. So I think putting that wool in there makes a big difference. So if you've got one of these things, or a desoldering gun like that, put some of that wool in there and it makes a big difference. make it work a lot better. And the other thing's been pointed out as well in the chat is there's also a filter on the front of the unit inside the inlet that can be clogged as well. It's got multiple filters, so if it gets through the handpiece and gets into there because you haven't got the steel wool and stuff in there, or the cloth filter properly seated in there, it could get into the unit and clog that one instead. Bit of a tip. So that's that done, that's that cleaned up. I think we can put it back together now, actually try it out, because I'm happy with these other caps. I mean, they seem fine. I'm not going to bother replacing them. So I've decided to replace some caps. I already pulled one out, this Sprague one here, and I'm going to do another one. I was going to leave them all intact, but it's sort of my own rule was to replace them on site because they do get old and they do fail. And the reason I've chosen these ones is because you got these heat sinks here, like you've got 2 here, you've got 3 more here, got these power devices right around these 2 capacitors. So there's potentially a lot of heat getting pumped into these. So if any of them are going to fail, it's likely to be these 2. So I've done this one already, which was a Sprague. I'm going to change this one as well now. The others I think I'll leave alone, although this one here is also by heatsink. Why do they keep putting them by heatsinks? That's a really bad design. Why do you do that? Anyway, I'll replace the other one. Now I'm wondering about this one. I'm going to replace it all anyway. I might do. So there's the cap pulled out. That's a 85 degree C. I was looking down here before it for some reason, but not a Sprague cap. Let me say Sprague did. I don't know if they're still around. They made high quality capacitors, always were really good. So if you see Sprague caps, usually you can be pretty safe that they're actually still alright, but as these are by the heat sinks, as I said, I want to replace them because you never quite know. It's in a position which would age the capacitors, and that's an 85 degree rated cap. So I'm putting 105 degrees in. Any better? I don't know, it might be worse than the originals, but the other ones are old. At least these are gigabit, at least another 10 years at least. You never quite know the other original parts. If you've got original parts in there, they could die next week, next month, 6 months time, a year's time. At least you've got brand new parts in there, you most likely have that problem. My instinct was to replace caps, right? Even though I checked them and they all tested okay, my rule is to replace caps if it's old, and that's just like, that is the way I work. So I've replaced those 2 by the heatsink, this one over here and this one by this other heatsink. These 2 big ones over here are still original. I left those intact. They were measured absolutely fine, and the big ones tend to be better anyway, my experience, so they're less likely to fail. They can fail still, but it's less likely. It's usually the smaller ones that go. The smaller the cap, the more likely it's to fail. That's my experience. Those ones there are done. I'll leave the big bulk caps, and we can put it back together and power it up and see if it actually works or not. It's back together. We're at the point where we can actually power it up for the first time and see if it works. Now I've done all the precautionary stuff and changed things I would like to change just to be sure they're okay. Now if it does work, I'll be doing further modifications to this thing. I'm going to be putting binding posts on the front panel, because it's actually got some holes here for binding posts on the board, right there. Just got to drill those out, put some posts in, and run them through to the back. There's a connector on the back here or something. You have to run them through somehow. There's sensing terminals over here, but you've got posts here for the connections. That will get done, because the rear panels, it's okay if you're in a rack mount system, but I'm not in a rack mount system. This will be something which will be sitting around. I'll plug into the front panel. Need to leave the cover off so we can see the smoke come out. Let's get set up. Here we go. So let's turn on power to the unit first. Switch is off. And you can't see the hopping meter. I should probably move that so you can see the hopping meter. There we go. Magic smoke and hopping meter. How's that? Nothing being drawn as expected. Noisy fan is very likely. These fans are known for it, and it's actually, oh, that's actually quite stiff. That's, yeah, that needs replacing. We'll get to that. Ready? Shall I touch the chassis or not? I haven't done an earth test on this thing. Well, there's the wire. It's fine. I should do an earth test to make sure. Hold on. I haven't done it yet. Earth test. Probably plug it. I can see the pin from here, but anyway. Earth test from here. There's the pin to here. 0.2 ohms. Yeah, no, whatever. Side there. 0.2 ohms. Heat sinks. Probably floating anyway. Yeah, they are. Okay, that's good. It's got an earth. Just to be sure. Okay, now you're ready. Okay, let's turn it on. I've rearranged things to try and see everything. This is slightly out of focus so you can see the back a little bit better. Ooh, sec down. What the hell does sec down mean? I don't know. It's drawing 13 watts, so 0.2 amps. There is no fan. Fan's not running. More investigation required. Looks like something's wrong with it. Excellent. So let's test some voltages. Just look at the manual, trying to figure out where things are. Still trying to find my way around this thing. So we've got a test point over here. Well, not actually a test point, it's just a component load. I need to be on voltage for a start. That would be really helpful. Voltage. And you just do DC and AC. Let's do both. So that is currently not on. Turn it on. Stick the probe on here. What do we get? Look at that, 5.0008. That's beautiful. That one's looking really good. No AC ripple. So that's testing between the rightmost pin on the, well, the left from the front. It depends how you look at it. The rightmost pin from the rear view of that connector on the back. And what pin's that? 2, 4, 6, is it? 2, 4, 5, 6. And pin 6 of wherever that IC is down there. There's an IC right there. That's where that one was. I'll do this again because I didn't record. U17 pin 7 right here, and the right hand leg of this resistor right here should be minus 12.1 volts. I'm getting nothing there. And to find what other things are on. Just going around now checking all the rails, and so far I've found absolutely nothing. I'm currently checking U106 on pin 8, getting nothing. Positive body, no stuff, nothing either. That's dead as well. Next one is U113 pin 13. See if we've got anything here. Nothing. So it looks like every single rail is missing from that particular system. So I need to backtrack. Shouldn't be that hard to find it. So it looks like the entire plus 15 volt rail is probably missing. Let's do some more tests. I think I need to go to here again, like that. Be careful on resting my hands, make sure I'm on a chassis. So you want pin 13, so that's 8, 9, 10, 11, there's nothing there. Okay, and that one there is one I checked before, wasn't it? Pin 8 there, there's nothing there either. So there's like no power at all in that section. So there are some fuses around apparently. I need to find these fuses, find out where they are. They look like a bit like resistors, but they're not. Obviously they're fuses. So I'll try paying a bit more attention this time. Someone in the chat said I was getting AC voltages on those. Let me check. Nothing that side. Yeah, that's why it rearranged. Okay. So yeah, 17 volts on that one, which I think is F8. Only on one side. Nothing that side. And this one here is 17 volts. Both of those fuses are blown. That's interesting. So what I'll do now, I've got power turned off. So I'm going from that 0 volt reference again, or the S reference, onto these fuses. So the get 0.5 ohms that side, and this one. So 0.5 ohms, right? So that's the secondary winding going to those fuses, right? So what I was actually trying to test for was a short, to see if there's a short on the outputs of these fuses, and there was nothing. Right, both fuses, there's no shorted outputs. That's looking okay. What I might do is diode mode, check it that way as well, just to be absolutely sure. Positive or negative. Makes sense, doesn't it? Diode mode. That's charging cap up, that's looking fine. That's on F8, this is on F3. Same deal, kind of, 2.66 volts. So if I check for shorts on the outputs of these as well, so that's pin 13 of this thing. No short there. And pin 8 of this one. Half volt drop, that's probably normal. It looks like it's just blown two fuses for some apparent reason. Weird. Diode bridges, there's a diode bridge here, let's check this. That looks alright. Get onto it properly. That looks alright. Other way around. Or the other two should also be the same. Look good in that orientation. Check the other way. Yep. 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 And yep. Diode bridge looks good. So now let's check for problems with the regulators themselves. I can probably go onto some of these pins. Maybe, if I'm lucky. That's looking alright. One should be a short because it's referenced the same. If I can get to it. You're having trouble getting onto it. Can't quite reach the bloody connectors. The other one I can't really get to either. Get to that side. I can get to one pin of both of them. That's what it looks like, and they both look okay. Oh, can I get it maybe this way, maybe? There we go, that side's alright. So that's U101. U104 can only check one pin on. So there's nothing obvious there. U101's one I'm interested in. It's definitely strange it's blown. Let's do one more check here on these diodes. That one of them will be normal. That's just charge up cap or something, that's fine. Yeah, that's all good. Can't find the actual faults there. I don't know what would have blown up. That's very interesting. I think I just need to replace the things and let's see what happens. So I've replaced these two fuses. Both of these are blown. So I put some ones in which I had. Oh no, when the clip leads fell off. And I'm going to power it up in a second once I put this clip lead back on again. And we're going to see what happens with the power supply rails. So I'm monitoring two rails, the plus and minus 15 volt rails. I think that's what they are anyway, that's what they should be. And hopefully they both come up. I just want to see if it comes up and dies or if it's, you know, something else going on. Right, let's try this again. Maybe get some smoke this time. We've got a fan. Both rails are there. She's alive. We're waiting to see if it dies. Fuses don't always go straight away. And also the magic smoke that doesn't always come out straight away either. They're looking rock solid, they're not changing around. That fan, AC ripple, nothing showing up on there. AC ripple, nothing at all. Millivolts, nothing. The same on this one. Give it a second to settle down. We'll probably go to 0. Anyway, so this is 1 millivolt, which means it's inconsequential. The fan will die soon on its own. Yeah, exactly. It does need replacing. Right, thermal camera test. See what we can see. So there's a few things getting warm around here. Not too bad though. It's 31 degrees, 48 degrees, that chip over there. 60 odd degrees over there. Which is big power resistor, so it's not surprising. I don't have the output turned on yet. The fan itself is also warm. 21 degrees, 22 degrees. I'll say warm over there. What's that? 33 degrees. What's getting warm over there? Oh, it's that processor over there. That's getting warm. Hopefully I was in shot most of the time, hopefully. We've got those heat sinks and stuff around there. So they're getting around 60 degrees in that area. So 64 degrees on the heat sinks. Which is why I wanted to change those caps. Because those caps are right next to those heat sinks and they're getting up to 60 odd degrees. 71 degrees is getting there. I actually think there's a device here which doesn't have a heatsink on it. Yeah. There's a device here to the left which doesn't actually have a heatsink on it, and that's getting up to 70 degrees. That's a bit stressy for it, isn't it? What if I get a clip-on heatsink and stick it on there? Probably a good idea. And other stuff around the board here, checking at the back, which you can't see in shot now. Like getting 40 degrees at the back there. Okay. Rear panel's looking fine. I've got something getting, yeah, 62 degrees, 66 degrees. There's a power resistor over there. So yes, those heat sinks are getting pretty hot. I'm glad I changed those caps. I think that was a good choice. But I'm not liking the fact there's another transistor there which doesn't have a heatsink on it, which looks like it actually needs one. Alright, so I've hooked up the Bryman here, or the EV log Bryman, to the rear terminals. That's currently saying minus 6 or 0.6 volts, and that's exactly what we're getting, is minus 0.6 volts. I'm not sure why it's minus 0.6. Anyway, constant current. How do I set this thing? Voltage set. Let's do 1 volt. I don't know how to use this yet. 1.0 volts. Enter. No. Current set 1. Okay, we've got current set of 1. But we see negative values. Now, I don't have the sense terminals hooked up. That could be something to do with it. So this is interesting. Current set 2. Is that actually consuming 2 amps of current? Disabled. It's also got overcurrent showing up. So this is on overcurrent, constantly on. So I think current set is 0.008. I thought I set that 1. Current set is now 1. Voltage set is 0. Did not remember it over power cycles. Voltage set is 1. Okay, try this again. And we're seeing nothing changing here. And it says it's saying over current. But no errors. This doesn't appear to be working correctly. What it says there matches that basically, but it's a negative value, so something's definitely going wrong there. So just in here, there's another fuse right there, F7, and it's open circuit. That might explain why it doesn't work. Alright, fuse is replaced. Now I don't actually know why this fuse popped, and I'm just going to see what happens. It could be the crowbar circuit's got a fault, it could be something else. If one of these output transistors are gone, it's possible. We won't really know until we try it out, so let's just try it out and maybe we'll get some magic smoke. Powered up. We're saying 0 now. Wasn't doing that before. And we have 0 on there. Voltage set 1 volt. Almost 7 volts. 1 volt. We get 1 volt. Current set 1 amp. Yep, that's working now. So we got 400 microamps being shown on display. So I can probably use a recalibration, but it's doing 1 volt, and it's obviously out slightly, but it is working. This can go to 50 volts. Voltage set 2 volts. Just going to double it for now. Yep, that looks good. 5 volts. Yep. 10 volts. 10 volts is looking good. 20 volts. Oh, 21. Oh, close enough. 21 volts. Yep. 30 volts. Good. 40. Good. 50. Good. 50. Oh, 52. Out of range. Yep, cool. That's fine. So it's doing 50 volts. That's working. Excellent. So let's go back down to say 1 volt. Yep, that didn't crowbar as a drop down. That was good. So it's actually looking like it's promising. Now obviously we need to load test this thing. That's not hard. I have a DC electronic load. Just there. So here's my load tester. I've got it set to high voltage range. Power this back up again. I think it always resets to 0 when you first power it off. Just do 10 volts. Nice easy one to think about. 10 volts, there we go. That's looking pretty good there. Current set 2 amps. So let's set this to, let's do a small load first. Let's do 0.1 amps. 0.1. System, let's do half an amp then. Half an amp, there we go. Turn the load on. Now you will get voltage drop through these cables, they're not ideal, and they're clipped onto the back. But it's doing half an amp here. The display says 497 milliamps, but it is working. So let's do 1 amp. Come on. So 1 amp, that's working there. Display said 997 milliamps. Again, discrepancy there. Let's do 1.5 amps. That's fine. Display says 1.497. 2 amps. There we go. And display says 1.998. So yeah, that's doing that. Excellent. So let's go back down to 1 amp. and I'll increase the voltage and see how it handles it. Let's do 20 volts now. That's fine. 30. So that's now 30 watts effectively. 40. Still fine. Yep. And 50. Still fine. So it's doing 50 watts. Let's increase the current. 1.5 amps. Well, if I do this right, it'll be helpful. 1.5. 75 watts. Yeah, still going fine. And let's go 2 amps. Which is 100 watts. And yep, it's managing that okay. Excellent. So it's otherwise working. 1 amp. We've done 50 watts again. Let's get the thermal camera back out and see how it's handling that. So there we go. That's what it's looking like inside. Maximum seeing so far is 72, which is over by these regulators over here. Over here we've got those diodes and the power resistor type thing, which is about 65. Diodes are about 58. Power transistors, one of them looks like it's doing more than the rest. Could just be reflections because, you know, the system, the way it works. The back ones are definitely looking warmer. Yeah, the back ones are definitely hotter. So it must be the thermals going through that chamber where it's pushing the hot air through, and the back of it's getting hotter than the front. I'll try and get it on camera. Maybe I can. You kind of maybe just see it. See the front one there. Oh, I'll put it on there, shall I? Front one's right there. And as you go back, it gets hotter and hotter. Back one's 33. Front one is 29. So there's not much difference, but it shows up. And this one here, if I put the crossroads on it, that's 29 on the front one that side. And over there, it's 34. So there is definitely a difference there. So the back ones run hotter than the front ones do. What's that? 74 degrees. What's that getting hot there? There's a resistor here, R223. That's getting warm. 77 degrees. Should probably find out what that is. But otherwise, it's looking alright. That could be a fix. But I'm not finished yet. I still need to put binding posts on the front panel. So I was getting confused by this because I can see R221 and R223 right here. Those aren't the actual parts here. This is the one that's getting hot. This one here, and that is not R223, it's R224, because that part number normally goes underneath the component. So that's actually options for different configurations of these things. They've got different population parts. So the interesting thing about this is that it shows us having two 3Ks in series. Well, we've got a single 0 ohm link and this thing. So that is actually a 3K resistor. So instead of having 6K across the output, it's got 3K across the output. 3K across 50 volts. So it's about, say, 17 milliamps. But it does work out as 0.8 watts. So it gets up there. That's a 2 watt part, so it should be right. So there we go. That's what's wrong with this thing. 3 blown fuses, 5 bad reefers, and a few caps which might have been alright, but change them anyway. But I think what really happened with this thing is that this reefer here, which is cracked on the side and actually got a hole in it, I think this one failed, tripped the output, which then blew all these fuses and messed it up. And also the other thing we've got to do is this power switch as well. That's still one thing we need to sort out yet, but I mean it's kind of working now. It's something I have to consider replacing in the future, and I have to try and find another one. I will be doing another video in the future, doing the binding post on the front, setting all that up with the front panel sensing and that sort of stuff, and probably doing something with the fan, maybe replacing it. Certainly I'll be doing, I think I'm going to be doing a temperature sensing fan setup on there. I've got all the bits to do it. It's mentioned on the EV blog from someone else's, well, other people have already done this modification. The fan gets a lot quieter because it only ramps up and down as needed to keep the system cool, and that's a far better setup. So I think I'm going to go with that, and I'm happy it actually works. I mean, there's plenty to fix, and it's all relatively straightforward things, nothing too complicated. Hopefully it's all good from now on. Obviously got these 2 caps I haven't replaced, but you know, they're probably fine. I'm not going to worry about it. So check out the other videos down below. Subscribe if you're not already subscribed, and click the bell icon to see my new videos. and there's a Patreon support link over there if you want to help support the channel, having to buy a bit of test gear like this to do videos about. Catch you later, and watch out for the next video.